Hello everyone. Today in this module I am going to explain you about soaps, detergents, cleansing action of soap and also scum. Right? Initially if you go with the soaps, so what are soaps? Soaps can be defined as sodium or potassium salts or fatty acids. And what are these fatty acids? Fatty acids are the long chain carboxylic acids that are seen in fats, usually vegetable fats. You can go with coconut oil, palm oil, olive oil, castor oil. In all these oils, vegetable oils, we see some glycerides. Glycerides or triesters, right? These are the fatty acids which are present in this coconut oil or castor oil. All these are treated with an alkali, right? And when they are treated with an alkali, a process called saponification manufactures the soap. So once again I tell you, soaps are the sodium or potassium salts of long chain carboxylic acid, namely fatty acids. Now here I am going to give you a chemical reaction which involves a soap formation like sodium stearate. We have stearic acid, we have stearic glyceride that is present in coconut oil, and that is treated with 20% sodium hydroxide solution. And then soap is precipitated, and in order to enhance the precipitation, we'll be adding a little amount of sodium chloride. So sodium chloride, NaCl, is like a precipitating reagent which precipitates or separates out the solid soap. And along with the soap molecule in this saponification reaction, we are obtained with one more important industrially used organic compound, namely glycerine. Yes, glycerine is also one of the important compound obtained during the manufacturing of soap. Right. So here I am explaining that C17H35COO. Like this, you have a triester, it's a glyceride, 35COO, and C17H35COOCH2. So this is a glyceride, and this glyceride is treated with aqueous NaOH, sodium hydroxide solution. You can also use potassium hydroxide. Usually the toilet soaps, bathing soaps are made with potassium hydroxide, and soaps are mainly meant for cleansing action. So here what is happening here, you can see I am taking 3 moles of sodium hydroxide and I am getting 3 hydroxyl groups, and I am breaking the compound here like this, and this is connected with 3 OH groups in such a way that you are obtained with glycols. So you know about alcohols. Alcohols are the organic compounds which are having 1 OH group. If there are more than one, if the organic compound is having 2 or more than 2 OH groups, then we call such type of organic compounds as diols, triols, and usually we name them as glycols or glycerol. So here this chain, here you can see there are 3 carbons, a propyl. So here CH2, CH and CH2. This chain is now linked with 3 OH groups. So here glycerol is obtained, right? So we call this as, if I number it as 1, 2 and 3, I call this, the IUPAC name of this compound glycerol is propane, put a hyphen, 1, 2, 3, put a hyphen, triol. So this is the name of this glycol or glycerol. We generally call this as glycerol. This is also having many uses like medicinal uses. Then what about the next? So here this moiety and sodium comes in contact, C17H35COONA. This is the formula of soap. We call it as sodium stearate. So the name of the salt or soap salt is sodium stearate. So this is nothing but soap. So this type of chemical reaction is called as saponification. So once again I repeat, soaps are sodium or potassium salts or fatty acids. Now, I'm going to explain you about the cleansing action of soap. So, soaps are the sodium or potassium salts or fatty acids, and these soaps are mainly used to remove the dirt from the cloth, right? So, before understanding the cleansing action, the mechanism, we need to understand the structure of soap molecule. Soap molecule is having mainly two parts, that is, it has a tail and also a head. The tail is considered as an hydrophobic tail and the head is considered as hydrophilic head. Why? Because the head is ionic and it is water soluble, and the tail is made up of hydrocarbon. It's an organic and it has alkyl chain and it is water insoluble. So here we go. So the formula of soap is C17H35COONA. And you can also represent the formula with one-line structure. So here I'm drawing a curved notation. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 and 17. So this curved line represents C17H35, the alkyl part, and then let us write down COO minus and Na plus. So this part is called the tail part and this is the head part. This tail part is considered as hydrophobic because it is a water repelling. It is water repelling, but it is oil soluble. So remember that. So this is an alkyl part, or you can also call it as an organic part. And coming to the head, this head part is a polar part wherein you can see two charges. Whenever the species consists of certain charges, that species is soluble in water. So here we consider this head as hydrophilic. This is hydrophilic, right? And this is water attracting. And definitely in contrast, it is oil insoluble. So here, this is the structure here. Once again, I tell you, the soap molecule is mainly having two parts, that is, it has a tail part as well as head part. The tail part is hydrophobic and the head part is hydrophilic. Because of the different characteristic features, here it is forming certain spherical group of molecules called as micelles. When a cloth with oily dirt is dipped in soap solution, the dirt is removed by the soap molecule. Soap molecule dissolves in water. Stearate ions are produced, and as you know, the hydrophobic tail, it attaches to the oily dirt, and hydrophilic head, it dissolves in water. And a number of, like hundreds and thousands of micelles are formed. What are these micelles? Micelles are the spherical group of soap molecules, and these micelles are very effective in pulling away the dirt from the fabric. Here we go. Here is a diagrammatic representation. Always dirt is oily in nature. When soap solution comes in contact with this oily dirt, the molecule aligns in such a way that the hydrophobic tail always comes in contact with the oily dirt, and the dirt is entrapped and it is pulled out. Here you can see the ionic end is away, and the hydrophobic tail, which we call it as an organic or alkyl tail, it comes in contact and adheres to the oily dirt. So here you can see these are micelles. Okay, so here I am representing a micelle. These are the hydrophobic tails. And these are the hydrophilic heads. And here you can see ion-ion repulsion. The negatively charged COO minus of one soap molecule undergoes repulsion with COO minus of another soap molecule. So never it undergoes precipitation, and due to ion-ion repulsion, these are away from each other. And such type of spherical group of soap molecules are called as micelles. And these micelles, they lift by rinsing the cloth, they lift away the dirt that is stick to the fabric. This is how soap molecules are effective in cleaning away or removing the dirt from the fabric. So here you can see these are all COO minus, and Na plus ions, they dissolve in water. So here we observe ion-ion repulsion. And not only that, these micelles, these are making the transparent solution into an emulsion. This emulsion is a colloidal solution which also exhibits Tyndall effect. Okay, so this is how soap molecules are exhibiting their cleansing action when they come in contact with the dirt. Soap is not effective with hard water. It is effective only with soft water. Then what is hard water? Hard water is water which consists of more number of calcium and magnesium ions. Yes, presence of calcium and magnesium ions hardens the water, and this soap is not effective with hard water because of the formation of scum. And again, what is this scum? Scum is a white color precipitate which is separated out in the form of a soap waste, and this is nothing but calcium stearate and magnesium stearate, and this scum decreases the efficiency of cleansing action of soap. Here we go. Like you know about the soap molecule C17H35COONA. This is nothing but soap, sodium stearate. When this comes in contact with hard water, this hard water consists of, as I told you, Ca plus 2 ions or Mg plus 2, that is calcium ions and magnesium ions. More number of calcium and magnesium ions interfere and they form a white color precipitate, and that precipitate is C17H35COO twice Ca, which we call it as calcium stearate, and C17H35COO twice Mg. This is magnesium stearate. These are separated out in the form of white precipitate. We call this as scum. So scum is nothing but soap waste. So what is the remedy? Then how can we effectively clean the dirt? Then there are some other organic compounds, namely detergents, which produce lather and which are effective even with hard water, right? So this is about scum.